Hi everybody. Today we're going to go through the review for the test on Unit 6. Have the original, so I'm just going to have to write these out. Sorry, it's going to look a little bit different than normal. So on the first problem, when we verify, first of all, you want to use the identities. If you're not using the Pythagorean identities and switching things to sine and cosine, then you're doing it wrong. This is to the fourth. All right. So in this first problem, they both have cosine squared. So we'll factor that out. So like this is gone and this is gone. It's dividing, obviously, like factoring is, but then you keep what you divided by. So this would be sine squared minus 1. Now the problem is the identity says sine squared plus cosine squared equals 1. So when we do this, when we subtract the sine squared, all right, and put this over here, then we end up with cosine squared is equal to 1 minus sine squared. And that's not what we have. The 1 is supposed to be first, and if you look at this, the 1 is second. Here the 1 is positive, here the 1 is negative. So they're not the same. They're in reverse order. So when you have the backwards order, when you're subtracting, you can take it out, like we can take this out and use this, use obviously the cosine squared, but the rule is then it has to become negative. So this is cosine squared, this is now negative cosine squared, but if you look at where you're headed, there's a negative sign in the answer. So sometimes that kind of gives you a little tip, like, ooh, how am I going to get a negative sign? And that might make you pay attention to it just a tiny bit more. And so now we would get negative cosine to the fourth. And obviously they match. For problem number 2, the top part of this is the Pythagorean identity. Right here, sine squared x plus cosine squared x. The bottom is also a Pythagorean identity. So when I say use the Pythagorean identities, I'm not kidding. So this is 1. Tangent squared plus 1 is secant squared. That is a Pythagorean identity. That's exactly what it says. And then 1 over secant squared, of course, is cosine squared. And now they match. And then for problem number 3, I don't know how I'm going to do this. We get here's we get the chance to switch everything to sine and cosine. Sorry. Do not cross off tangent squared because the top part is subtracting, and subtracting and dividing are not inverses. They do not undo each other. So tangent squared is sine squared over cosine squared. You will get that. You will not get cosecant squared is 1 over sine squared. That will not be on your formula sheet. And then, of course, I'm just going to leave this tangent squared alone for right now because I'm not really sure what's happening here. And this has a minus 1 up top. So now the sine squares cross off. And so now we have 1 over cosine squared minus 1 over tangent squared. Well, 1 over cosine squared is secant squared. And then secant squared minus 1 is tangent squared. This comes out, use Pythagorean identities, and now we have tangent squared over tangent squared, which is exactly what we're trying to get. Now for problem number 4, we're switching the identities. We're switching to the sum and difference. So that whole next section on the formula sheet. So we're trying to get to 15 degrees. Lots of ways to get there. 60 minus 45, 315 minus 300. So there's lots of places that are 15 degrees apart. I'm going to use 45 and 30. So cosine of 45 minus 30. So the formula says to go cosine first angle times the cosine of the second angle. Then you have to use plus. All right, so if this is a minus, then that means that's a plus. Then the rest of the formula is sine 45, sine 30. Now we take out all of it. Get rid of the word, the angle, and replace it with looking at the unit circle. So what is the cosine of 45? Radical 2 over 2. No more word, no more 45, all of it's gone. Cosine of 30 is radical 3 over 2. Again, just looking at the unit circle. Sine of 45, radical 2 over 2, and the sine of 30 is 1/2. Now when you multiply straight across the top and bottom, so we get radical 6 over 4 and radical 2 over 4. And when we put this together, they have a common denominator, so they're pretty easy to write together. Problem number 5 with the tangent. Again, when it ends in a 5, just use 45. So I'm going to use 45. And then 285 minus 45 is 240. And 240 is on the unit circle. And you'll have a unit circle. So if you're not looking at a unit circle when you're doing this, get one, look at it. You'll know that 240 is on the unit circle. So the formula says that we're going to do the tangent of 45 plus the tangent of 240 divided by 1 minus tangent of 45 times the tangent of 240. Remember, tangent is y over x, sine over cosine. It's all the same thing. So if you have to divide out your two pieces on the unit circle, because tangent is not on the unit circle, then you're going to have to divide that out. We know the tangent of 45 is 1, and the tangent of 240, it's in that third quadrant, it's a positive. So that stays positive, and then the tangent of 240 is the square root of 3. On the bottom we have 1 minus 1 times the square root of 3. So if we just clean this up a little bit, this is where we have. Now, in order to get rid of the radical in the bottom, you have to multiply by the conjugate, which is to change the sign in the middle. It is the bottom that's in charge of that. So you do the conjugate of the denominator, and the numerator just gets what it gets. Distributive property, FOIL, however you want to do this, make the box. This is the difference of two squares, so the bottom should be the easy part. That's going to just be 1 minus 3. The top, you might have to go through all 4 parts. So we get 1. Outside is a plus radical 3. Inside is another plus radical 3. And then the last two, radical 3 times radical 3, is just a plain old 3. This is always the pattern of this problem, of the style. You're going to end up with a whole number first and last, and radicals in the middle. So we get 4 plus 2 radical 3 divided by negative 2. Now we have to divide negative 2, so we have to think of this as 4 divided by negative 2 and 2 radical 3 divided by negative 2. If that helps you see it a little bit better. So then this will be negative 2. This is going to be obviously minus radical 3. Now there's a 1 there. If you want to write that 1, of course you can. It's unnecessary, but it's not wrong. Now for 6 and 7, we're going backwards. So the idea is that all you're going to do is kind of match this to what's on the paper for the identities. So we know in these identities, if it starts with the word cosine, then it's cosine. If it starts with the word sine, then it's sine. If the only word in the whole problem is tangent, then it's tangent. So it does kind of identify itself. What you have to do is identify the pattern. So we know this is cosine. We know the two angles are 4x and 3x, because it goes first angle, second angle, first angle, second angle. So we know that's what we're doing. The issue is, what is the plus or minus sign? So if you're adding with the cosine, then you end up subtracting in the actual kind of figuring it out, right? So then this would be the opposite of that. And now you just do this, 4x minus 3x. So this is just the cosine of x. Nobody knows that. You can't do anything with it, so you don't bother. Number 7. Of course, you can see that there's only one word in this whole problem, and that's tangent. And also, tangent is the only one that has a fraction. So there's several ways That's kind of giving itself away. So when we do this one, we know that it is, first of all, tangent. You know that the first angle is 7 theta, and the second angle is 6 theta. Theta is just a variable. Whatever the sign is on top, it will match what goes in here. So just subtract 7 minus 6, and we get the tangent of theta. On the back. These are double angle formulas. So for number 8, double angle formulas mean draw a triangle. One triangle. Label your sides. Use Pythagorean theorem to figure out the missing side. So we know the cosine is 1/3. This is adjacent over hypotenuse. We also know that we're in the first quadrant. So I'm going to just draw this first quadrant. Draw my triangle. Adjacent's 1, hypotenuse is 3. So now we know that 1 squared plus x squared equals hypotenuse squared. So when we subtract the 1, we get 8. Take the square root of 8. I'm just going to leave it radical 8. Tangent, like the way tangent is, it's kind of a pain. We did a problem like this in class, I think. So you can reduce the radical or not. That's completely up to you. So your choice there. You're going to have to do it eventually. It's just a matter of when you want to do it. So the formula we're going to use is the one on the paper that says 2 tangent x over 1 minus tangent squared. Oops, this is minus. So we need the tangent. It's in the first quadrant, so it's positive. So we're going to have 2 over 1 times, this is your angle. The tangent is radical 8. I guess I'll put that over 1. That's really unnecessary, but that's what I did. And the bottom is 1 minus the square root of 8 squared. So the top is just 2 radical 8. I'm not really sure why I put those over 1s. All right, this is unnecessary. And the bottom is 1 minus 8. Because when you square a square root, the square root's gone. So this is going to be 2 times the square root of 8 over 7. So that's the answer. The problem is this needs to be simplified. So when we break down 8, it is 2 square root of 2. So now I have this 2, that's this guy. And now the square root of 8 is 2 square root of 2, and the whole denominator is a 7. So when you multiply this, you get 4 square root of 2 over 7. Problem number 9. We know that the tangent now, and this is written this way on purpose, where you can't tell where the negative sign goes. You're going to have to graph it and figure out which one is negative. That matters, which one. So we have to take a look at the graph here. It says we're in the second quadrant, so over here. This is opposite, this is adjacent. Here's your angle. So this is 6 radical 2. That's obviously up, so it's positive. This is 7, so we went to the left 7, so this is the one that's negative. Pythagorean theorem, 6 square root of 2 squared plus 7 squared, drop that negative. When you square this, you square the 6 and you square the radical. You could also put it in the calculator as long as you use parentheses. So it's 36 times 2, so that's 72 plus 49 equals x squared. This is 121, which is a perfect square. So our hypotenuse is 11. So we're asked to find the sine of 2 theta, and the formula is 2 sine theta cosine theta. So the 2 is a 2. I'm going to make it as 2 over 1 just because we're going to have lots of fractions. The sine is opposite over hypotenuse, so 6 square root of 2 over 11. And the cosine is adjacent over hypotenuse, so negative 7 over 11. Straight across the top, straight across the bottom. 2 times 6 is 12. 12 times negative 7 is negative 84. The square root of 2 is still there. 11 times 11 times 1, 121. That's it. And for the last one, we have that the cotangent is 1 over 6. Well, I don't know about cotangent, but I know that tangent is opposite over adjacent, so that means this is adjacent over opposite. And we're also in the first quadrant. All right. So we have adjacent is 1 and opposite is 6. Pythagorean theorem, 1 squared plus 6 squared equals x squared. So 1 plus 36. So 37, take the square root of that, and that's going to go here. Now for the cosine of 2 theta, you have 3 choices. Pick one. It doesn't matter. I'm going to use the cosine squared minus sine squared. So the cosine, these are both positive, so we don't have to worry about plus or minus signs. The cosine is adjacent over hypotenuse, and the sine is opposite over hypotenuse. When you square the radical, it just gets rid of the square root sign. Square root of 1 is 1, or square 1 squared, rather, sorry, is 1. And then 6 squared is 36, and this is a 37. And this will give you, all we have to do, we have a common denominator. You just have to do 1 minus 36, negative 35. And these always kind of work out like this. I'm not saying you might have a radical, you might not, but you always end up with like kind of a messy fraction. So that's just the pattern of these style of answers.